All right, Mac 248, production procedures. This is Tuesday, the 24th of March. We finished up chapter 8 today. I'm teaching you guys to read these chapters in this book, to kind of skim them through and look for good ideas and data and backup for the paper that you're going to write at the end of the course, the 3 to 4 page paper. So I kind of picked up today where I left off last time. We were talking about the 4 different times that make up lead time. Now today I'm going to segue that into thinking about lead time as something to be managed, not to be ruthlessly eliminated. Okay? We need to manage lead time and not look at it as an enemy. What we really want is the truth. Okay? Wishful thinking can take over here, and we can tell people when things are going to be due just when we think we can do. We'll make a wild stab at it, whereas what we really want is the exact time. So you may do a lead time management study, do a couple of adjustments, and then find that your lead time is longer than you hoped it to be. Should you just throw your hands up and quit? No. Now you know for certain, and that your numbers are good, and now that you know for certain how long it takes you to get something into your customer's hands, you're way better off. So in saying this, I'm trying to instill in you the idea that we can manage this. We just have to go through a little difficulty and a little trouble to get to certainty about it. And so we said that the first place, if you're going to improve your lead times, or you're going to get the truth about your lead times, the first place you want to attack is queue time. Queue time of those 4 times before was up to 80% of the time it takes to get in and out of our manufacturing plants. That's the time spent waiting to be processed, waiting to be set up and worked on. 80% of the time. So we attack that. And in order to attack that, then our first order of business becomes priority sequencing. What job gets done first? Well, since we're looking at our stuff so closely in the theory constraints, we're separating the bottleneck resources and non-bottleneck resources and green tag parts and red tag parts and all these things. We have what really amounts to be a fairly easy sequencing for bottleneck resources, and non-bottleneck resources, we can use the old traditional ones for them. So I asked you to think about priority sequencing rules for your work here in the CIM program, in the Computer Integrated Machining program. You're in Mac 233, where you got to make like 30 parts. You're in another class called Mac 245, where you got to make some molds, and you're in Machining 4, where you're making a whole bunch of NIMS parts any way that you see fit to make them. Well, we came up with all these different priority sequencing rules after having done the homework, which is question number 2A and B on page, I don't remember what page, but anyway, the first available machine. Since we have so much demand, whatever's available, that's the job you go work. This is probably the most practical one on the board. How about the one I want to work on? I'll wait for a machine and then I'll work on this one. All right, if I can't get to my machine though, then I better have a backup. I better have a job ready to go, my second preferred job. So then the first due date. Some of your classes have due dates. Mac 233 does not. But you look at the due dates for when they're going to be per the course or the syllabus, and you work on those first and knock them out. Then we had an interesting discussion about whatever had the most thorough print, the most nailed down, fully defined job that was out there. And in some places, engineering is not settled on what they want yet. You'd be kind of foolish to get halfway through a project and then find that they changed a major dimension and you got to start all over from the beginning. So you elect to do the one that we've done the most times, and you're the most sure of the print. Then here's another one. Most hours to complete. This is one I like. I would look at jobs and I would say, wow, this one's got the most work on it. I'm going to do that one first. Because then at the end of this course, I'm doing a whole bunch of little jobs that I can knock out in an hour or two, as opposed to 5 or 6 hours with a whole bunch of planning. Then there is the tooling. Do I have everything? Yeah, well then I'm going to work that job. If I have enough tooling to get the job done in this 3 or 4 hours that I'm going to be here, I'm going to do that job. But if I don't have it, I might be able to do part of it and then move to another job while I wait for tools to be gotten. So we move then on to scheduling, into more detail in the theory of constraint scheduling. We talked about the 2 different kinds of lots that there were. In the goal, they cut their lot sizes down 50% and then they cut them again. But they didn't really say, like they do in this book, that they should be separated. Transfer lot is the lot that goes in between machines. Process lot is the overall purchase order. This is going to be on the test so that you can distinguish them. You may get an order for 200 of something, and yet you find for the smoothest flow through the shop, you break that up into 25 parts per lot. So you're going to have 8 lots in transfer for 1 process lot. All right? So we went over a lot of things in the book that went into more detail about that. But the main thing was the book showed us the drum buffer rope tied to the bottleneck, and the rope tied to the non-bottleneck resources for assembly. They gave a whole nother scenario for the use of that, and I thought it was quite good to read that. How you can exploit the drums, how you can elevate the drums, and we talked about that for quite a bit. I had to take quite a bit of notes through there. So, what are the overall contributions to finish up the chapter of the theory of constraints to an organization that successfully implements it? Well, they get certainty. They get certainty, certainty, certainty. They get certainty on due dates for when they can promise their customer will get it in their hand. Customers will pay for this certainty. They will pay more for a company that can tell them for sure when their part's going to be there. Why? Because then it increases the steadiness of the flow through their plant. The more certainty you have on these due dates and when you're going to have things in your hand, the better. But we have to allow for Murphy's Law by building buffers into our system that are not excessive. We don't want piles of inventory, but we want inventory in front of the bottlenecks and behind the bottlenecks and before assembly to make up for any disruptions that may come. The bottleneck might break down. If there's a buffer of parts after the bottleneck, then that hour lost is not going to hurt us. So you get certainty of due date. You get certainty of throughput. That means there's no wasted effort. You're only working on the stuff that's making you money. And it enables you to find your non-profitable product lines and either sell them or stop making them. And really just concentrate on the bottleneck resources makes us concentrate on what makes us the most money. So you get certainty of throughput. The last thing you get is a nice, easy schedule tied to how fast your bottleneck can process parts. When you know how fast it can do that, then you release the material in the beginning of the plant accordingly, and you get a nice smooth flow through the plant and certainty again on the due dates. A nice easy schedule, a nice certain and easy schedule. All right, I did the last thing was a chapter 8 review. Look on the page that I showed you for the conclusions of chapter 8. Next, we're going to work on chapter 11, starting on page 158 in the book. And your take-home quiz for due the 31st, which is a week from today. Today was the 24th. Is your paper outline. I want a thesis statement. I want to know what you're going to write your paper on, and I want a basic breakdown on the outline to make a 3 to 4 page paper. I don't want less than 3 pages, and I don't want a whole lot more. But I will talk with each one of you about this in my office, or anybody that wants to have some input as to what their paper is going to be. Look on the syllabus for outcome number 4, and it will describe what that paper is going to accomplish for you. Thank you, and we will see you Wednesday.